Okay, so we're going to do section 15.5 today, and we're going to look at angle relationships for angles that are created when we have segments inside and outside the circle. So what I'd like you to do is draw two large circles. The larger the better, so if you can put maybe one on the top half of your paper and one on the bottom half. We want to start with two chords inside one of the circles, and try not to make them diameters. So something like that. And
do we make them equal in size?
they don't have to be, the circles don't have to be equal in size, no. Okay? And so what we want to do is measure these angles, 1, 2, 3, and 4. And then also, if you can identify the center of your circle, then you can use the central angles to measure these arcs A, B, C, and D. So you're going to need the central angles to measure those. And then for the second circle, you're going to draw two secants. And you're going to measure this angle 1, and then measure arcs A and B. So go ahead and work on that. I'll come around and help you with that if you need help figuring out the arc measures. I can help you with that, but you're going to need to know where the center of your circles are. To measure arc A, for example, you would need to draw two radii like that, and then measure that angle. That angle A, if that's A degrees, then the arc is A degrees. So remember, a central angle is the same as the arc. So you might want to do those lightly or in a different color or something like that, like I did, so that you can go back and erase them. So once I measure that angle and I label it on the diagram, I can go back and erase those so that they don't make my diagram confusing. Okay, so when the angles intersect, when the segments intersect inside the circle, we take half the sum of the arcs to get the angle. And when the angles intersect, or when the lines intersect outside of the circle, the angle is half the difference of the two arcs. So half the sum here, half the difference here. Okay, and those are summarized in your notes, in your books on page 830. Go ahead and open up to page 830. So on page 830, angle 1 is the intersection of two chords. So it's the intersection, it's the half the sum of arc AB and arc CD. So angle 1 is the average of arc AB and arc CD. That's page 830. Okay, so use that concept to go ahead and try problems 4 and 5, please. Okay, so for problem number 4, the angle inside the circle is half the sum of the two arcs. So the measure of angle MPK, which is this angle right here, which is the same as this angle, is going to be half the sum of 61 and 111. So this would be 61 plus 111 divided by 2, and what do you get? Half of 172? 86 degrees. So that means the measure of angle MPK is 86 degrees. Okay? And then the same idea for problem 5, except that we know the angle on the inside. So if we call this X, then we'd say 58 is equal to 82 plus x divided by 2. So the angle inside is always half the sum of the two arcs. And so that is 116 equals 82 plus x, and x is what did you say?
34.
34, thank you. X is 34 degrees, so the measure of arc PR is 34 degrees. Okay, and then the other relationship that we looked at earlier today, we had two secants, which was this case right here, but all three of these are actually all the same. It doesn't matter if you have two secants or two tangents or one secant and one tangent. The angle that's created outside of the circle is always half the difference of the two arcs that are created. Okay? So in all three of these cases, you do the big arc minus the small arc and divide by 2. Big arc minus the small arc divided by 2, or big arc minus the small arc divided by 2. So all three of those cases are the same as the one that you did on your binder paper earlier. Okay? So you can see that applied in example A. To find angle, to find the arc X, we know the angle outside is 25 degrees, so 25 is half the difference of the two arcs, 83 and X, and so they got X equals 33. Okay, why don't you go ahead and try finishing example B, and then try problem 8. Probably physics.
Mr. Dixon, are you going to teach the second, like, in this course? Like, are you going to teach algebra 2?
I'm not sure, probably, but I'm not sure. Whoever signs up for it. Okay, so example B. We know the angle X is half the difference of the two arcs that are created. Now, they didn't tell us what this small arc is here, but we know that there's 360 degrees in a circle, so this would be 360 minus 238. And so what is that minor arc?
122.
122, does everyone agree with that? Okay, and then if we take the difference of those, we get
116.
116, and half of 116 is 58 degrees. Okay, and then down here we just have X is half the difference of 161 and 67, and that is 47. So X is 47 degrees. Okay, so we did skip on page 832 at the top. There's another relationship that we didn't talk about. It's the same as when you have an inscribed angle. Remember we said when we have an angle on the edge of the circle created by two chords, that's called an inscribed angle. And the inscribed angle is half of the intercepted arc, so X equals 1/2 of the measure of arc A. When we have a secant and a tangent intersecting on the circle, the same thing exists. That angle that we get is half of the intercepted arc. So that's what they have here. The measure of angle ABC is half of arc AB. So if you can remember, when the point's on the circle, the angle is half of the intercepted arc. It doesn't matter if it's an inscribed angle like this, or if it's an angle created by a tangent and a secant. If that point is on the circle, it's going to be half of the intercepted arc. Okay? And so go ahead and try 6 and 7. Okay, so for problem number 6, the measure of arc PN, we know that the angle is half of the arc. So because this angle is on the edge of the circle, so 61 degrees is half of the intercepted arc PN. And so that means the measure of arc PN is 122. Multiply both sides by 2 and you get 122. And then for problem 7, there are actually a couple ways you could get angle MNP. This angle, actually no, I was thinking of the other angle. So yes, angle MNP is half of its intercepted arc. So that's half of 238. What's that? 119. Any questions? Okay, and then all of this stuff is summarized in one table on page 834. So the one we just did, we said that it doesn't matter if it's an inscribed angle or an angle created by a tangent and a chord. The angle is always half of the intercepted arc. When the angle is inside the circle, it's half the sum, so we have addition. And if the angle is outside of the circle, like in these two cases, then it's half the difference. So we use subtraction when the angle is outside of the circle. So half the sum when it's inside, half the difference when the angle is outside. Okay? So all that stuff is summarized in that table. And then if you go to problem 10, you have to use several of those properties that we just learned. So go ahead and try that. See if you can work through all the details there to figure out what is the measure of arc KN. Okay, so there are several ways to solve this problem. You can actually do this in one step. If you recognize that since that's 79 degrees, then the angle right next to it has to be 101. And so now you can say, if we call this arc X, the one that I labeled in blue is KN, that's what we're trying to find, we can say 101 is half the sum of 86 and X. And so then 202 equals 86 plus X, and then X equals, what is it, 202 minus 86? Is that 116?
Yeah.
So you get 116 that way. I think what a lot of you did is you found this arc first, and then subtracted from 360, and that's fine also. So to do it that way, you would say 79 degrees is half the sum of 48 and arc PN. And so then you get 158 equals 48 plus PN. And so then PN would be 110. And so if that's 110, then you could say arc KN is 360 minus 48 minus 86 minus 110, and I think that'll work out the same. Yeah, that gives you 116 also. Okay, so either way, and there might be other ways also, get X equals 116. Any questions on those? Okay, how about questions on last night's homework? Haley? What page was that? $19, okay. So what we want to do for this one is draw the whole circle, and each of these would be 590 because we have 1180 cut in half, or cut into 2 equal parts is 590. This piece is 225.4, and let's call this length x. So we learned that when we have 2 intersecting chords, the products of the 2 pieces are the same. So 225.4 times x has to equal 590 times 590. And so then x equals 590 times 590 divided by 225.4, which is 1544. And so if this is 1544.36, they asked for the diameter of the circle, which would be this whole length AB. And so AB then is 1544.36 plus 225.4, and so that is 1769.76 feet. Is that okay? Okay. Sure. Okay, number 25. All the radii are 4. Let's see. Describe 2 different methods you can use to find BC. Okay, so to find BC, you could use the relationship that we talked about. External times full length equals external times full length. And so if we call this x, external times full length equals external 4 times the full length of this secant segment, which is 12. And so then x squared equals 48, and x equals the square root of 48, which is 4 root 3. Okay, so there's one method. The other method is to recognize that when you draw a radius to a point of tangency, you get a right angle, which gives us a right triangle. And so this right triangle has 4 and 8 for the hypotenuse. So if we want to find x, we just do x squared plus 4 squared equals 8 squared. And so x squared equals 6, or x squared plus 16 equals 64. X squared equals 48, and then x equals the square root of 48, which again is 4 root 3. So you get the same answer 2 different ways, either by using the Pythagorean theorem or by doing external times full length equals external times full length. Any other homework questions?